Hello everyone, we are the team of AP086 who have done the project named Water Quality Analyzer. We are the team members who have done the project under the guidance of Mr. P. Shyam sir and Mr. S.K. Irfan Ali sir. Let's go to the introduction part. We have inspired to do this project having two strong reasons. One is water contamination has been studied as one of the leading causes of death and illness in the world. Many people die from contaminated water every year. Water contamination is also a serious issue in industries, irrigation, and aquaculture. Second one is public and government ignorance and the absence of water quality checking systems. Traditionally, water quality detection is done manually when water samples are taken and sent to the laboratory, but this process requires a lot of time, cost, and human resources. Here we come up with an efficient solution to design a water quality analyzing system by using D10 nanoboard, which is FPGA, and an efficient parallel processor. Now let's go to the detailed design architecture, which is supported with the main 4 blocks. Those are information block, decision making block, data transfer block, and display block. Initially, the information block consists of sensors which collect the values of different water quality parameters from the water bodies, and that collected data will be transferred to the FPGA board. Here, FPGA board acts as decision making block. It specifies the quality of water based on the type of water to be tested and the sensor's data received from the information block. These values will be sent to the cloud. Let's see the decision making flow diagram. If all the sensor values are within the range, it will indicate water is excellent to use. If any one sensor is out of range, it will indicate water is good to use. If any two sensors are out of range, it will indicate water is fair to use. If more than two sensors are out of range, it will indicate that the water is not suitable for the specific usage. Cloud acts as a data transfer block between boat and mobile application. Whatever the data that is sent to the cloud, that will be transferred to the mobile application. In the display block, when the user selects the mode of application, then it will display values of all the parameters of the respected block in the mobile application. Then user will guide with the quality of the water. Now, let's see our hardware design. This is our hardware setup. Our design contains mainly 4 blocks. Firstly, the information block, which contains sensors dipped in water bodies. For that purpose, we use pH, temperature, turbidity, total dissolved solids, conductivity, dissolved oxygen sensors, and samples from different types of water bodies. All the sensors are connected to the D10 nanoboard via Arduino. The D10 nanoboard processes the given data and makes decision. Let's see the process happening even clearly in FPGA board. In HPS part, we are implementing our design using Linux LXDE operating system. We have accessed the GPIO pins from pre-installer tool, which supports both FPGA and cloud simultaneously. We have collected the data ranges of the quality parameters of the water for different purposes. These values are taken from the Indian standards of different types of waters, World Health Organization standards, and some of the standard organizations. Let's execute the code and see the output. These are the values of the 5 different parameters. Mainly, 2 types of data transfers between FPGA and mobile app via Azure Cloud. One is data transfer from mobile to FPGA board, which is used to trigger decision-making block on FPGA board by sending type of water to be tested. Second one is data transfer from FPGA to mobile, in which cloud receives the data from FPGA board. That data will be transferred to the mobile app. For this, a storage account is created in the Microsoft Azure Cloud. In that, a container is created for storing the data. Now, the data from the FPGA board or app will be written to a file, and this file is sent to the Azure storage container that we have created. These files are accessed by the FPGA or app based on the requirement. App consists of 3 pages. First one is user login. The user can log in directly into the app by giving his name and phone number so as to maintain the data in the name of the user. Second one is selection page. This layout consists of 5 fields which are drinking, industrial, aquaculture, agriculture and domestic. The user needs to select the type of water to be tested from the given 5 fields. This selection will be sent to the FPGA board for further processes. Third one is decision page. This layout consists of 2 blocks which are the decision block and the parameter values display block. The parameter values and the decision statements obtained from the FPGA board will be retrieved and will be displayed in this page. Let's move to our demo video.
These are the various kinds of water that we have collected. This is the water from water plant. This is the water before purification, and this one is after purification. And this one is a pond water, and this is a wastewater. This is our setup. Now we are going to test this water. That means drinking water. We have done with the setup. This is the program in the FPGA board. It will read the sensor data and will make the decision and will send all the data and decision to the app through cloud. Now we will run this program. We can see that all the sensor data is read into the FPGA board and it will make the decision and automatically will send to the cloud. Now we will display it in mobile app. Now this is the mobile app. User need to log in first. Now I am going to test this water in drinking area. We can see that this water is excellent to use because all the parameters of this water is within the range. So we can use this water as drinking water. Now I am going to test it for this water, which is raw water. Now I am going to run this program. So I am selecting the area of testing here. Let's say drinking water. It's worst use because all values are out of range. Next I am going to select one more area. Let's say domestic. Yeah, since it's raw water, it's excellent to use. We can use it as domestic purpose. Now we are going to test this pond water. Yeah, now I'm going to run this program. Now let's select the area of testing as aquaculture. We can see that pH and dissolved oxygen are out of range, so it's average to use. Now I'll select it for drinking water. It's a worst to use because all the values are out of range. Now we'll test it for wastewater. Let's run the program. Now I'm going to select the area of testing. Let's say drinking water. Yeah, we can see that as it's a wastewater, it's worst to use for drinking water. Now let's select another section, domestic purpose. Even domestic purpose also, it's worst to use.
By using our design, we can reduce the cost, time consumption and human resources due to the absence of using laboratories for water quality checking purpose. Our design makes the water quality testing easier and it's also accessible to all the people. From this, we can save a lot of innocent people living and non-living creatures who are going to affect by water contamination.